Hello and welcome to our learning series on Agile transformation, a learning series brought to you by Sternbridge Technology Consulting. I'm the host, Kenny Gibbons, and I'll be taking you through this learning course. Welcome to today's episode 3 of our learning series. Today's episode is part of our continuation on Agile fundamentals. Today I will discuss the Waterfall methodology. We are covering Waterfall to give further context as to why Agile was created and to help build a more rounded understanding of the technology delivery process. In the last episode on Agile fundamentals, I gave an overview of the history of Agile and the core principles that drive Agile frameworks and processes today. Just a reminder, we have broken down the topic on Agile fundamentals into multiple episodes. This is part 2 of the Agile fundamentals episodes. As always, if you'd like to understand more about the goals of the course and the topics we will cover, watch our introduction episode, episode 1. So with that, let's get started with today's topic. Today, we will give a high-level overview of the waterfall process, the overall process, its challenges, and benefits. Even though this course is focused on Agile, the waterfall process is still used successfully in technology and non-technical environments today. There's a time and place to use waterfall, similar to how there's a time and place to use Agile. In fact, some of the most successful large organizational scaling practices for Agile have elements of waterfall in them. And because this learning is about applying Agile to transform industry processes, having an understanding of waterfall is an important tool in your Agile transformation toolbox. My experience as an industry practitioner is that it's always best to have a strong understanding of both processes to be able to apply frameworks and concepts that will work best for your organizations or teams. Waterfall methodology has been around longer than Agile, with it being attributed to being started in 1970. This is in part the reason why the Agile Manifesto was created, to fix some of the shortcomings of the waterfall methodology in modern technology processes. And as I mentioned in the introduction, waterfall gets applied successfully in both technology-based and non-technology-based projects due to its principles. Its core principles are 1, that it has well-defined and planned sequential phases. 2, it focuses on documentation and really works well when there's defined documentation templates up front. And there's a plan-driven approach with defined stage gates, deadlines, and milestones. Because of these core principles, waterfall generally works extremely well in scenarios where these principles must be applied. Some of those examples are, let's say the project is well defined. The scope, timeline, and budget is known up front, and there should be very minimal changing or deviation from that plan. Or a heavy element of documentation is needed to ensure that the project, and in this case, the technology project, meets regulatory requirements. This is very critical in the world of regulated software like GXP in the life sciences industry or SOX in the financial industry, which is why in regulated industries, you will still see waterfall approaches being utilized by these organizations. Now, with that being said, Agile practices can still be successful here. It just takes some modification to the methodology to fit into those regulated controls. This is why having an understanding of both Agile and Waterfall is key. We'll cover more of this concept in Agile within GXP regulation in a future episode where we'll break down how Agile delivery can still be successful and meet all the documentation requirements that are necessary. But in order to understand that episode, having an understanding of the waterfall process is crucial, and being able to combine that into waterfall methodology is an important next step as part of that. So let's get into the waterfall process. Waterfall project delivery consists of standard phases dedicated towards delivering the entirety of that phase before moving to the next phase. In most projects, although it's not necessary, there's usually a sign-off on a phase before moving to that next phase. The 6 phases are Phase 1, requirements gathering and analysis, Phase 2, system design, Phase 3, technology implementation, coding or configuration, or all 3, Phase 4, testing of the software, Phase 5, deployment of the software, Phase 6, maintenance and overall support. In general, each phase will usually last in the magnitude of months, with a waterfall project usually taking a year to multiple years to complete from kickoff to deployment. So now let's get into each phase of the delivery process. Phase 1, requirements gathering and analysis. In this phase, the project is just getting started. There's usually a stage 0 before this phase in the industry. Let's say there most likely previously have been a kickoff with executive stakeholders or sponsors to align on what is needed throughout the longevity of the project. The project would have been created with governing dockets like a charter or similar concepts. Now, the waterfall process doesn't cover this stage 0. It jumps in at phase 1 with the requirements gathering and analysis. But again, because this is intended to be an industry practice course, this stage 0 is covered on a lot of large-scale waterfall implementations that I have been part of. Going into phase 1, again, the requirements gathering and analysis, all of the focus is on gathering, documenting, analyzing, and organizing all of the requirements that are needed for the entire system. By the end of this phase, the goal is to have all of those requirements documented, essentially 100% captured. The requirements drive all of the decisions to be made from here on out. So now let's apply this to a realistic scenario to help give some further insight on how this works in the industry. Consider a large enterprise system that is intended to support 10,000 users globally. Again, the goal of this phase is to capture all of the requirements for the entire system. It could realistically take up to 6 months to interview the necessary users and subject matter experts, and then document and analyze their needs. There could be hundreds, sometimes thousands of requirements that need to be documented, analyzed, and grouped into a single repository. Generally, each of these requirements follow a standard documentation template that has specific information that is needed. These are usually called user requirement specifications, or URS. For non-user facing system needs, these would also be captured, and these would be in a technical requirement specification. Think of things like security or performance requirements. So at the end of this stage, there would be one master document that captures all of the requirements in one place, with all of the details captured per requirement. For a project like this, all this would most likely be captured in a system designed to capture requirement specifications, but I've also seen them captured on paper. Phase 2, the system design phase. Now that all of the requirements are documented, system engineers, architects, and other resources can now begin building the system design. The end goal of this stage is to create a holistic system design covering all of the requirements that were documented in phase 1, both the user and technical requirements. Within this phase, there are also sometimes additional requirements that are found during the design process. But again, the goal is to not focus on the requirements, to focus here on the system design. All the requirements should have been done and documented in a perfect world in phase 1. As part of this phase, there will be a lot of different designs and sub-designs as part of this step. General solution architecture, data flows, database schemas, software configurations, and design flows for functionality to be delivered as part of this. Coming out of this phase, there should be a full template on how to build the system to meet the requirements. Going back to the example we discussed in phase 1, for really large projects, this step could take a similar time frame of multiple months to half a year. It is not uncommon to complete this stage gate 6 months or even a year after the project kickoff has started. Coming out of this phase, you should have a complete set of documentation that provides the roadmap on how to build the solution to meet the requirements. Now let's go to phase 3. System implementation, development, and configuration. After all of the system design is completed, so all of the system diagrams, technical architecture, technical requirement specifications, and all the other accompanying documentation, the system can now be developed. The development process may vary depending on what kind of system it is. If it is net new software custom code where development will be needed to build the solution from scratch, or if it's a large out-of-the-box platform, it might be more towards system configurations, data models, and updates to the out-of-the-box application interfaces. In my experience, no matter how out-of-the-box a system is, there will always be a need to do some form of customization to meet the business workflows that are within the industry. The technical documents produced during the design phase are broken down and planned into work during this phase and followed by the development/configuration team that is going to deliver upon this work. Following the scenario of a large global deployment, a project, again, may not get started in this phase until a year, if not 18 months after the initial kickoff. So again, to put that in an industry term, you're not truly working on the configuration or the system itself until 18 months after the first users were engaged. So you can start to see where some of the challenges start to appear in the waterfall process. Again, if the scope is well known or you know the scope can't change, it may not be a problem, but there could be a lot of changes within that 18 months in this example that could impact the overall end product or end software solution. Phase 4, testing. During the testing phase, the software is tested against the requirements and system design documented in phases 1 and 2. In an ideal state, especially in regulated industries, every requirement and technical specification needs to be linked to a test procedure that proves that the system is working as intended in the documentation. You might hear this called the traceability matrix in the industry. Now, these testing scenarios can and usually cover both positive testing scenarios, where they test directly a requirement or what is stated within that requirement. And a simple example here is the user form shall have a mandatory field for inputting a user's first name and last name. So there'd be a test written explaining how to navigate to the page, and then testing that the field is mandatory before you can submit that form. We also cover negative test scenarios, where it might test what happens when a user puts in, let's say, 1,000 characters into the name field, just for an example. Negative scenarios would follow a risk-based approach, but are generally used in some form of testing. In that scenario, if a user puts in and is able to put in 1,000 characters into that name field, firstly, you want to make sure that the system just doesn't crash because the database is not able to handle that. And then second, it usually has a conversation around, how many fields or characters should that field have. Just an example in some of the negative scenarios that I've seen and kind of how to think about that process in this testing phase. So when we talk about this example, you can imagine that if there are 250 requirements documented, there are generally at least 400 plus test scripts to test those requirements. There are software solutions and best practices used to help ensure maintainability and traceability from test scripts, but you still have to navigate, manage, maintain all of these test scripts back to those requirements. Once the tests are created and drafted, there's usually a phase within this phase during the testing where the testing team will conduct non-official test runs. This is especially important in regulated environments. This makes sure the testing documentation is accurate and easy to follow, and it helps to pick up early defects. Regardless if this is done or not within the practice of the software team, there is usually one or multiple sets of official test runs that count towards the final documentation. Test runs will capture if the test passed or not, and any defects that caused the non-passing of that test. If the test didn't pass and a defect was raised, the development team, testers, developers, project managers, and product leads will need to then review each defect, classify it, prioritize it, and determine if it should be fixed or not in the release. The classification usually follows guidelines based on the impact of the defect to the software. Once the test scripts are ran, it generally kicks off another cadence of meetings where the team will review defects on a recurring basis, usually at least daily, to track and manage all the defects reported. If a defect is fixed, it will be flagged for retesting, and then the team will need to rerun the test script to determine if it is now passed or not. The reason why I called out the formal runs versus the informal runs during that process is because if a defect is found during a formal run, and this formal run will be used in official documentation, there's usually a very stringent process that needs to be followed to document, prioritize, fix or not fix, and ultimately sign off on the defect. If the testing phase is not in a formal run, the level of documentation is generally not mandated and can be bypassed, and therefore a lot of fixes can be done quicker without the formal sign-offs or documentation. But in regulated industries, formal test runs are mandated and need to be documented and captured. We'll go more into that in the GXP for Agile episode that we'll talk about later. There's one last item during this phase that I would like to cover. In the example I keep using, the testing phase of a project may not occur until 8 months after the initial kickoff, if not longer, depending on how much the system development work is needed. During the majority of this time, the end users are not really involved during any of this process outside of the requirements interviewed. They may have signed off on the requirements document after the requirements phase, but they wouldn't have seen the requirements come to life in the actual solution that is being developed. So, in addition to the other subphases that we talked about with the formal and non-formal runs, there can also be another subphase within the testing area that gets broken down into 2 additional processes. Phase 1 is the phase we previously talked through and described, which is what is a lot of times called the verification phase. This phase ensures that the software is verified against the documented requirements. There's usually another step added for this user feedback, which can be called user acceptance testing. During this phase, a subset of end users are asked to go in and use the software to verify that it can work for their business need. Now, in this phase, there are usually defined test scripts that the users are following to test their acceptance in the solution. A lot of times, this is also done in an informal and then a formal fashion as part of the software development process within large organizations or the regulated industry, which we keep giving examples of. And the intent of this is to make sure that that end user can follow a business process during the test scripts. And as the users are following the test script, they leave notes and update the steps for pass-fail on if the software meets their expectations and the acceptance criteria that is within that test script. This is generally where one of the biggest challenges presents itself in Waterfall. If the software does not meet a business process or is not very usable from a user standpoint, the business and technology teams have two options. Option one, they update the software functionality to meet the requirements, or option two, they make minor adjustments or leave the software as is. The project has just spent, in the example that we've been giving, the last 18 plus months in this case to build the software that the end users are now seeing. It usually takes millions, as I mentioned, over a year, if not multiple years. And if there's a fundamental flaw or problem in the software, it can be extremely costly and time intensive to update it. In my experience, especially in the user acceptance testing, when you're in this phase, there's a heavy reluctance to make any changes or any big changes that might impact that ROI that has just been given across that time frame. So again, this is where one of those challenges really starts to come up in the waterfall process, is if something is fundamentally off or that system is just not usable for the end users, it can really create a large setback in both cost and time to get that software into production so that it can truly bring value back to the business. And this is why in Waterfall, it is best used if the requirements and needs are very well defined and accurate upfront. As each phase progresses, it becomes more and more costly to update or change the requirements and functionality. Remember one of the core Agile principles from the last episode: welcome changing requirements. This is the opposite of the Agile philosophy and why one of the core principles for the Agile Manifesto was created. Phase 5, deployment. Now, for regulated industries especially, this phase does not look too different between Agile and Waterfall. In non-regulated industries and where there's less stringent SDLC processes, the two phases may look slightly different, but the end goal is still the same: deploy the working software to production. And in this case, let's use deployment to production environment as an example. I won't go into environment strategies in this lesson, which would include validated versus non-validated environments, testing, staging, etc. I'll cover those when we talk about GXP in Agile. So for now, let's just focus on this example of taking that software and deploying it into a production environment where the users can use this working software. I mentioned some of the documents in the deployment phase, and one of those being deployment scripts. In the deployment phase, there's generally a set of deployment scripts that teams will follow to ensure the deployment and all of the configurations are met that match the tested parameters and order of operations that are needed to deploy that infrastructure. In modern practices, this is where concepts like infrastructure as a code appear, and CI/CD that I mentioned in lessons before, where the environment and application infrastructure provisioning process can be automated. Regardless if this is an automated or manual deployment process, once the end-to-end solution is deployed into the production environment, both the application layer and the infrastructure layer usually coming as part of that process, there are usually some steps taken to ensure the deployment was successful and that the solution is working. These steps are also usually documented and approved prior to the deployment process, and they're usually a light touch. You might hear them called smoke tests after the application is deployed. If a defect is found, the team would need to determine if they can fix that defect following all the formal operating procedures and processes that are needed, or if they need to redeploy or start again from that process. Once that process is successful, the deployment steps are signed off and that software is available for use by the customers and the business. And the last phase, maintenance and ongoing support. Again, this phase doesn't really look different between Agile and Waterfall, similar to how the deployment phase starts to look very similar between both frameworks as well. Once the deployment is done, there's usually a period of what is called hypercare. During this period, the team remains very focused and hands-on with the customer base to ensure timely responses to questions or any defects or problems that occur in the software. And the reasoning here is that since users are really using the software to run their business processes for the first time, there needs to be more support, especially if they find new defects or enhancements that are needed to successfully run their processes. This phase can usually last anywhere from a few weeks to a couple of months, depending on the number of users and the scope of the functionality that was deployed. As the software gets used by more and more users, there's generally less defects and enhancements reported, so best practice is to have the software move into a more typical support lifecycle. You may have heard things in the industry like level 1, level 2, level 3, and level 4 support processes. I'm not going into all the detail here on that, but in general, there's a whole team and set of procedures dedicated to supporting the users, where level 1 is the most simple, like password reset needs or general questions, the whole way up to where level 4 is where you need subject matter expertise from the actual software development team or the vendor itself to help look into it. And the last thing I will add with the maintenance and ongoing support phase is that once this phase is ongoing, it doesn't mean that there won't be any further releases. The waterfall process can be started again, or an agile process can be started in parallel after that release cycle we just talked through. And while the maintenance phase is ongoing, the next release process is generally less scope, but that is not always the case. There's a whole environment strategy, release process strategy that goes into play, especially after that first release is done. You see this a lot in the application lifecycle, where there may be frequent releases in, let's say, the first couple of years, first year, first 2 years of the software. Then, as the software becomes less and less supported, there'll be less releases. But in general, it's best practice to have multiple releases even after this initial first release. So that's the end of all the phases within the waterfall process. And in general, thinking back to another agile core principle, the highest priority is to satisfy the customer. I would argue in a waterfall process, the highest priority is to deliver well-documented software that meets the documented specifications. And this is one of the big reasons why the Agile Manifesto was created. And we'll talk through some of those challenges that this creates in the next section of this with the challenges in Waterfall. Let's now move on to summarizing some of the challenges in the Waterfall process. And I want to emphasize here that Waterfall does have its benefits, and we mentioned this at the beginning of this episode. We covered where it works well if the scope and overall project is very well understood, defined up front, and ultimately you don't expect very many changes once the project kicks off. Because of this, it is also used a lot in the regulatory industry because of its documentation-heavy approach. And understanding when to use Waterfall and Agile is important. Understanding each of the methodology's challenges is an important tool in the toolbox when trying to make that decision. Now, the first challenge here is the length between phases. In the scenario I talked about as we walk through the Waterfall process, each phase generally lasts anywhere from 3 months to 6 months, in my experience. By the time the project is kicked off, by the time the user starts seeing working software, it is not uncommon for that duration to be over a year. The risk here is that requirements may have changed, users' demands may now be different, and technology capabilities may have greatly expanded during this time, especially in today's day and age where AI is exponentially increasing its functionality, able to adapt once these processes kick off. The second challenge is that the process is very inflexible to changes. The further the project is in each stage gate, the more costly any changes become, both from a time and cost perspective. It puts the waterfall process at risk if a change comes very late in the process, especially if it's a fundamental change to the requirements or overall workflow. Which leads us into the third challenge, late end user feedback. Because end user feedback does not truly take place until the testing phase, and sometimes, and most of the time in my experience, post the deployment process, it can be very challenging to know how usable and valuable the software is to the end users or the customers. Yes, there are usually sign-offs during the requirement and design phases to help here, but there's a world of difference between reading a requirement and seeing how it comes to life in the software. And this could mean major changes like fundamental business process flow changes, or it could even be super small changes that make the software easier and more intuitive to use. Again, speaking to my experience, even small intuitive changes, if caught early in the process, can make a world of difference to users. If you wait to make those changes at the very end, even though they're small, they can add up, as there are usually a lot that can be made to increase the ease of use. So if there's 100, that could really impact the timing it takes to get through all of those, even if they only take, let's say, a day for a developer to fix. And with this, there's another theme and another challenge where there's a reliance on design perfection. There's a reliance that the requirements, system design, and ultimately how the software is developed is perfectly captured and documented in those phases, including all the edge cases that were defined and thinking that they would have to be thought through. In my experience, it's very hard to think through edge cases and challenges until working software is available and able to be used. In addition, all of those user experience enhancements and minor updates can't be done until the user can see and use the software. And because of this, Waterfall has challenges in adapting to changing requirements, causing risk in design. This is one of the main reasons why the two Agile core principles of working software is the primary measure of success and deliver working software frequently. It's to help ensure that these changes can be made as the software is being developed and worked on versus waiting until the very end. I mentioned at the beginning of this episode that a core principle of Waterfall is documentation. And in this case, it is also a double-edged sword, in that Waterfall focuses on documentation primarily over software usability. This is one of the drivers as to why Waterfall works so well in regulated document-heavy industries, but by doing so, the focus on the software usability for users is lost, and you can see the usability of software be greatly impacted as part of that process. And then lastly, another common challenge here is problem or defect detection, especially late in the process. Because the testing phase doesn't happen until one of the last phases of the project, there's generally a lot of problems and defects found when that testing process begins. It can be very challenging to predict the scope or the magnitude of these, but in general, the more software functionality that needs to come together, the larger number of problems and defects that will occur. It is not uncommon in this phase for this process to take months because of all the functionality that gets deployed together for the first time. In my experience, within designs and the implementation, those designs are never perfect. It's impossible to predict every scenario, every edge case that I mentioned before, and this is where the impacts are felt. The Agile principle of delivering software as frequently as possible was made in part to combat this challenge. And as I mentioned in the episode before, the further software code drifts before merging into the final product, the more problems that will occur from that drift. So that concludes today's episode, our part 2 of our walkthrough of Agile fundamentals within the broader learning series on Agile transformation. I could do a whole course on waterfall concepts and projects, but since this is a course focused on Agile, I just wanted to focus one part on waterfall to help you understand the core concepts, circumstances as to why Agile was created. As we mentioned throughout this episode, waterfall and Agile both have their benefits and challenges. Understanding both of these will help you apply the best methodology to your organization for the software that needs to be developed, configured, and deployed. In my experience, some of the best technology transformations that I've seen and supported actually combine concepts from Agile and Waterfall to meet the needs and the current maturity of the organization. In next week's episode, we'll continue our multi-part learning on Agile fundamentals, and we'll focus on the Agile process, some common methodologies, and challenges in Agile. As always, I'm Kenny Gibbons, and thanks for listening to our course on Agile transformation. Hope you have a great day.